All right, we are going to look at the Pythagorean Theorem, but I just wanted to kind of go over our last goal, which is that you could use the geometric mean to find missing side lengths. So we looked at a couple things. Remember, this is from we're looking at from the altitude. And so the altitude of a right triangle forms three similar right triangles, and because of that we can see that x here is the geometric mean between 4 and this number, so 16. So x equals the square root of 4 times 16, which is the square root of 64, which equals 8. So this is 8. And then we have our side ones. It's always going straight down from whatever side you're looking for is 8. Well, there's not another side, so we go around to this side. So it is the z is the geometric mean of 8 and 20. So it is the geometric mean of 160. And y is the geometric mean of 4 and 20. So y is the geometric mean of 4 times 20, which is the square root of 80, which is about 9. So this here is 17.9, and this is 8.9, but you're looking at down, and if there's not a 2 parts straight down from the side you're looking for, then you would go around to the full size. All right, so that's what we did last time. Now we're going to look at finding missing side lengths using the Pythagorean Theorem. So we've kind of looked at Pythagorean Theorem. We looked at it when we looked at the distance formula on the coordinate plane, but this unit's just focusing on right triangles. So we also see this in all right triangles. So the Pythagorean Theorem says in a right triangle, the sum of the squares of the length of the legs. So the legs are the sides that make the right angle. So the sum of the squares, so a squared plus b squared, will equal the hypotenuse squared. So the length of the hypotenuse. Hypotenuse is always straight across from the 90 degrees. That's your largest side. So if I were to take the area of this square that I would make by making a square from A, and the area of B that I would make from making that, I would find that those two areas added together would equal the area of whatever C is. So we can find the length based on that Pythagorean theorem. So let's look at this is the using the geometric mean to find to prove that, but we're going to go on to here. So I know Pythagorean theorem says the legs squared, the two legs squared, so x and 8 are both legs squared. So x squared plus 8 squared equals the hypotenuse. So 12 is the hypotenuse because it's pointing straight from the right angle, so equals 12 squared. So we're going to simplify that out. X squared plus 64 equals 144, and then I'm going to subtract 64 from both sides as I'm solving for x, so x squared, that cancels out, equals 80, and then square root both sides, so x equals 8.9. So when you're looking at these, you want to just set it up and then solve for x as you're working your way through. And again, it's just like that distance formula that we had also earlier. But the key is that you know which ones are the legs. So legs make up the right angle. So what's on the side on both sides of the right angle are my legs. So 5 squared plus 8 squared will equal the hypotenuse squared, which is x squared. So once you have it set up, then you want to square first before you add. So 25 plus 64 equals x squared. So 89 equals x squared, and square root both sides to solve for x because the square root will cancel out that square. So I get 9.9 9.4339, so 9.4 equals x. So we're just going to go out one decimal place here on your homework. So try this one, pause the video, try it, and see what you get, and then we'll go through it. So my legs here are 6, so 6 squared, and x squared, and that equals the hypotenuse squared. Hypotenuse is straight across from the right angle. So 36 plus x squared equals 144. Subtract 36 so we can get x by itself. Then you're going to get 108. And then square root of 108 is 10.4. So square root both sides, so we get rid of the squared. So x equals 10.4. So there are some common Pythagorean triples. Pythagorean triples are going to give you all whole numbers, and they all come off of our main through 4. So we have the 3, 4, 5, and then any ratio of that. So this would be 2 times all of those, 3 times all of those, and so forth. So those will perform where we'll get all whole numbers. So that's why they're called a Pythagorean triple. There's 5, 12, 13, 8, 15, and 17, and then 7, 24, 25. These two are commonly used in construction. So if you can recognize that they're a triple, so this 39 is 13 times 3. This is 12 times 3. So they've got a 12, 13, so this would have to be 5 times 3, or 15. So you can use Pythagorean theorem, or you can see if you can recognize a Pythagorean triple. All right, I am going to, that's all that we're going to do on this video. If you have any questions, let me know.